In elementary, non-calculus-based statistics, we defined the mean of a set of numerical values is the sum of the values divided by the number of values. We also defined the median to be the middle value when the values are placed in order. So what if our values are those of a random variable x? By using the frequentist interpretation of probability, we can interpret the probability of an outcome as the frequency that it occurs if the number of trials is large enough. For example, suppose a fair six-sided die is rolled a large number of times. What's the mean value of the outcomes? So our probability mass function for the experiment is going to be, suppose we ran the experiment 10,000 times. Then we'd expect to see a 1 appear 1/6 of 10,000, or 1,666 2/3 times. While we could work with this, let's try to avoid dealing with fractions. Since we're multiplying the number of trials by 1/6, let's assume we repeat our experiment 600 times. If we do that, then we get each outcome 1/6 of 600, 100 times. And so the sum of all our outcomes, well, that'll be 100 1s, 100 2s, 100 3s, and so on. And so our sum will be, and so the mean outcome will be. Now this should look familiar. In fact, it's what we did when we computed the expected value of the random variable. In other words, the mean of a random variable is the expected value, e of x. What about the median? So as before, we can imagine repeating our experiment a large number of times. Well, we already have a table for that, so let's use that. If we repeated our experiment 600 times and put the outcomes in order, we'd see something like the following. We'd have 100 1s, followed by 100 2s, followed by 100 3s, and so on. Since there are 600 values, the median value will be between the 300th and 301st value. And that will be someplace between 3 and 4, so the median would be 3.5. What if we had a different PMF? So let's find the median of the random variable. So again, suppose we repeated our experiment a large number of times. If we repeat our experiment, say 100 times, we'd expect to see, and putting these values in order, we get 20 1s, followed by 10 2s, followed by 40 3s, followed by 30 4s. And so the 21st value is a 2, the 31st value is a 3, and the 71st value is a 4. And if we repeated our experiment 100 times and put the values in order, the median would be between the 50th and 51st values. And these fall into this range, so both of these values are 3, and so the median is 3.